Bismillah wassalatu wassalamu ala Rasulillah. Welcome guys to my channel. Today I'm going over the May-June 2021 variant 2 of the IGCSE Chemistry exam. So let's get started with question 1. The symbols of the elements of period 3 of the periodic table are shown. Answer the following questions about these elements. Each element may be used once, more than once, or not at all. So these guys over here, these guys are the only metals and the only elements that can be shaped. So it's either sodium, magnesium, or aluminum. They all work. Question B has only 2 electrons in the outermost shell. So the structure of this element should look something like this, which therefore would form a 2+ charge. And we know that the only element that would form a 2+ charge would be magnesium. Forms an oxide which leads to acid rain. So that's sulfur, because sulfur makes sulfur dioxide, which forms acid rain. So it's SO2, or it's just sulfur. Forms an ion with a 2- charge. So that's sulfur again, because its structure looks something like this. It has 6 electrons in the outer shell, and with forming an ion it gets 2 more electrons, so it makes a 2- charge because it got 2 electrons to octet. So the answer is S. Question E is extracted from an ore called bauxite. That's aluminum. That's bauxite is the name of the aluminum ore, which should be memorized. F doesn't form an oxide, so if we look at all these elements, there's no such a reason for them not to form oxide except for argon, because it's a noble gas, meaning that it doesn't react with anything. So it's definitely argon. Forms an oxide with macromolecular structures. That's silicon, because silicon forms an silicon oxide, which is basically the sand molecule. So it's silicon. Forms an amphoteric oxide. That's aluminum again. Aluminum, because this aluminum oxide reacts with an acid as a base and with base as an acid. Exists as a diatomic molecules. That's chlorine, because it's in group 7, which forms the Cl2, I2, Br2. All these are diatomic molecules, so it's Cl here. Forms a binary compound with hydrogen that is a strong acid. So the possible acids that can be formed with hydrogen from these elements are 2 actually. We have chlorine and sulfur. But since in the question it says a binary, meaning that there is only 2 molecules in the acid, so it's the only option is Cl, HCl, the acid HCl, because the other acid that forms with the sulfur here, the sulfur, is sulfuric acid, H2SO4, which has 3 different molecules, H, S, and O. So the answer for J would be Cl, because HCl is a binary acid or a binary compound. Question 2. Silver has an atomic number of 47. Naturally occurring atoms of silver are silver 107 and silver 109. State the name given to atoms of the same element with a different nuclear numbers. So that's isotopes. Complete the table to show the number of protons, neutrons, and electrons in each atom and ion of the silver shown. So these guys all have the same number of protons, which is 47. Number of neutrons for each one is different. Basically, the answer is 60. That is for silver 107. For silver 109, it's 109 minus 47. 109 minus 47, that's 62. Now the number of electrons, since this silver is an atom, it would be similar to the proton number. For this one, this is an ion, a plus ion, lost an electron, so it would be 47 minus 1 electron lost, that would be 46. So it would have 46 electrons. Now let's jump to the next question. Complete this definition of relative atomic mass. Relative atomic mass is the average or mean mass of naturally occurring atoms of an element on the scale where the C carbon 12 atom has a mass of exactly 12 units. A sample of silver has a relative atomic mass of 108. Deduce the percentage of silver 107 present in this sample of silver. So if we think about it, we have silver Ag 107 and silver 109. The average mass is something in between them, like exactly in between. So that means that the average of 2 is taken, so it's like 107 plus 109 divided by 2, which is equal to 108. So we can see that the percentage of 107 is exactly 50%, because if it was higher, it would have had a different relative atomic mass than this one. It would be either higher or lower than 108. Silver nitrate is a salt of silver made by reacting silver oxide with an acid. Write a formula for the acid which reacts with silver oxide to form silver nitrate. So from somewhere there is a nitrate ion that came in to the silver ion, and we know that this is an acid. And the only nitrate acid that we know is nitric acid. And we're asked for the formula for this acid, which is HNO3 basically. Aqueous silver nitrate is colorless solution containing silver ions. Describe what is seen when aqueous silver nitrate is added to aqueous sodium iodide. So when this reaction happens, so we have silver nitrate plus sodium iodide. A double displacement reaction happens, which looks like this. So one positive ion goes with the negative ion from the other compound, and the other positive ion goes with the other negative ion. So we would end up with something like this: sodium iodide, silver iodide I mean, plus sodium nitrate. Okay, and this silver iodide is a solid and gives a yellow precipitate. So it's yellow precipitate. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium iodide. Include state symbols. So let's look for some space in here. So like I mentioned before, the full reaction that happens looks something like this. So it was silver nitrate plus sodium iodide, one positive ion with the negative ion here, and the other positive ion with the other negative ion from the other compound. Therefore, we end up with silver iodide plus sodium nitrate. Now we're gonna add the symbols of these. So we had an aqueous solution of silver nitrate, aqueous solution of sodium iodide, then a solid of silver iodide, and an aqueous solution of sodium nitrate. Now let's write all these in the form of ions. So we had an Ag plus ion in the aqueous state plus NO3 minus ion in the aqueous state as well. Then we have sodium ion in an aqueous state. Then we have the I minus ion also in the aqueous state. Then we have the whole compound of the whole solid of silver iodide in the solid state plus sodium ion, which is still in the aqueous state, plus nitrate ion plus NO3 in the aqueous state. So if we look at this whole reaction, we can see that there is some spectator ions, which does not change in the reaction. They enter the reaction as a form of ion and end in the reaction as a form of ion as well. Like the nitrates, the nitrate started as an aqueous ion and ended as the same aqueous ion. So we're gonna eliminate this from the full ionic equation. Same as the sodium, it started as an aqueous ion and ended as an aqueous ion as well. So we're gonna eliminate it, and we end up with these two guys here, silver and iodide ion, which gave us the silver iodide solid. So the full reaction would be something like this. The net ionic equation would be sodium ion plus iodide ion gives us, don't forget the state symbols, aqueous, and that gives us silver iodide solid. So let's write this down in the space. Oh, so it's silver in the aqueous state plus iodide in the aqueous state, which gives us sodium iodide in the solid state. Now let's go to question D. In the positive test for aqueous nitrate ions, aqueous sodium hydroxide and one other substance are warmed with the nitrate ions. Name the other substances of the gas and the gas formed. The substance that is heat is warmed with the nitrate ions is aluminum. It's something that you have to know from the aluminum. It's something that you have to know from the test of ions unit. And the gas that is formed is ammonia, which is something as well that you have to know from the test of ions. When silver nitrate is exposed to sunlight, silver is formed. Name the type of reaction which needs light to make it happen. That is photochemical reaction. Photochemical reaction. Members of two homologous series only react with chlorine in the presence of sunlight. Name a member of this homologous series. So over here we're talking about alkanes in general, because we know that there should be sunlight or UV light to make an alkane react with a chlorine or a halogen. So basically we're naming any alkane. So I would choose to say propane. You can also say propane or methane, ethane. You guys get the point. Name two products that formed when the compound in I reacts with chlorine. So let's stick with propane. So the product would be chloropropane, and the other product would be HCl, hydrogen chloride. And be careful, guys, with this question, because if you say uh, hydrochloric acid, that would be counted as a wrong answer, because the acid should be dissolved in water, which is not the case for hydrogen chloride that is formed from this reaction. It's just a gas, so it wouldn't be an acid. Therefore, hydrochloric is a wrong answer. Question 3. Sodium hydrogen carbonate is found in baking powder. When sodium hydrogen carbonate is heated, it forms three products. So that's the sodium hydrogen carbonate heated up, forms sodium carbonate, water, and carbon dioxide. Name the type of reaction that takes place when sodium hydrogen carbonate reacts in this way. So basically, that is thermal decomposition. Calculate the volume of carbon dioxide formed at room temperature and pressure when 12.6 grams of sodium hydrogen carbonate is heated using the following steps. Determine the mass of 1 mole of sodium hydrogen carbonate. So we know that the mass number of sodium is 23, H is 1, that's the mass of hydrogen, then carbon is 12, and then oxygen is 16, and we have 3 oxygen molecules here, so we're gonna multiply this by 3, and always, if you do not know the mass numbers of any element, you should refer to the periodic table, or just even if you know, you gotta make sure, so always check the periodic table for this. And the mass number is 84. So the mass number of 1 mole of sodium hydrogen carbonate, or aka the mass number of sodium hydrogen carbonate, is 84. Calculate the number of moles of sodium hydrogen carbonate used. So we're gonna use this formula that says mass is equal to moles multiplied by mR, or molar mass. So over here we have the mass number and we have the mass. So that would be so we know these two variables over here. So it would be a division. It would be the mass over the mR, which is equal to 12.6 divided by 84, which gives us 0.15. Now determine the number of moles of carbon dioxide formed. Over here we can see that the ratio of NaHCO3 to carbon dioxide CO2 is 2 to 1. So if we have 0. So for each 2 moles of sodium hydrogen carbonate, we're gonna have 1 mole of carbon dioxide. Therefore, we're gonna divide this number by 2. So it's 0.15 divided by 2, which gives us 0.075. So that's 0.075. Then calculate the volume of carbon dioxide formed at room temperature and pressure. So at room temperature and pressure, we have this formula that says volume is equal to 24 multiplied by moles, which is 24 multiplied by 0.075, and that gives us 1.8 decimeter cubes. Lime water is aqueous calcium hydroxide. Carbon dioxide turns lime water milky because a white precipitate forms. Write the formula of calcium hydroxide. So let's look at the ions of calcium hydroxide. So we have calcium with a 2 plus charge here, and OH with a -1 charge. So we're gonna follow the crisscross, which says that the number of charges in the negative charge goes to the positive charge, and the number of charges in the positive charge goes into the negative. Therefore, we're gonna have the compound looks like this. So the one would go with the Ca, so we'd have Ca. The 2 goes with OH, so you're gonna have OH between brackets multiplied by 2. So that's the formula of calcium hydroxide, OH2. And then the white precipitate that forms when lime water turns milky. So that would be calcium carbonate, because we had carbon dioxide reacting with calcium hydroxide, which forms the calcium carbonate, CaCO3. A student carries out an electrolysis experiment using the apparatus shown. So over here we have a wire, carbon electrodes, and dilute aqueous sodium chloride. The student uses dilute aqueous sodium chloride. State the name given to any solution which undergoes electrolysis. So the solution used in electrolysis is called electrolyte. Hydroxide ions are discharged at the anode. Complete the ionic half equation for this reaction. So this reaction forms water as well as oxygen, and if we want to balance it, we have 4 electrons here, so we gotta have a 4 over there, and then we have 4 oxygens and 4 H's. On the other side we have 2 H's and 3 oxygens. So 1, 2, 3. Here we have 2, so 1 plus 2 is 3. Therefore, we're gonna add a 2 here to balance it. Now we have 4 hydrogens, 2 oxygens here, and 2 oxygens here. So that's 4 and 4 electrons. Explain how the ionic half equation shows the hydroxide ions being oxidized. So as we see here that the hydroxide ions lost electrons because electrons were products. So we're gonna say that OH ions lost electrons. Describe what the student observes at the cathode. So that's the cathode over here, which has hydrogen gas as a product, since we have dilute sodium hydroxide. Therefore, describe what the student observes at the cathode. So that's the cathode. This is the cathode, the negative electrode, which attracts a positive ion. So to know the positive ions that forms the positive ion that forms in the positive ion that goes to the cathode, we want to look at the electrolyte, which is in this case dilute aqueous sodium chloride. So since it's a dilute solution, always hydrogen will form if it's a dilute solution. Therefore, hydrogen gas would form here. So over here we're gonna have H2 gas, which will cause us to see bubbles forming in the cathode side. Now write the ionic half equation for the reaction at the cathode. So we have H plus gaining an electron to form H gas or H2 gas, because H2 hydrogen gas exists only as a diatomic molecule. So this equation is not balanced because over here we have 2 hydrogens and the other side we have only 1. so we gotta add 2 here and 2 to the electrons, and then our equation is balanced. The student repeats the experiment using concentrated aqueous sodium chloride. Describe what the student observes at the cathode and the anode. So in the cathode, we'll still have hydrogen gas forming, because even though we're using a concentrated solution, sodium is more reactive than hydrogen in the reactivity series. Like, the sodium is here, hydrogen is somewhere here, and we have some X, Y, Z, A elements. So these are all elements in between the sodium and hydrogen. Therefore, since the sodium is more reactive than hydrogen, it won't form on the cathode, but hydrogen would form still. So we're gonna say that bubbles will still form in the cathode, and in the anode, we're gonna say that a green gas would form or would be observed, because when the solution is concentrated, the Cl molecule is coming instead of the OH, which was the anode product, and the OH was the one going to the anode in the diluted solution. Question E2. The student added litmus to the solution after the electrolysis of concentrated aqueous sodium chloride. State the colors seen in the solution. Give reason for your answer. So as we said before, we had NaCl solution and H2O. In this reaction, we got rid of Cl ions and we got rid of hydrogen ions, H+. So we lost one hydrogen and we lost one hydrogen and we lost Cl. So we're gonna end up with these two, Na and HO, or OH in other words. So that would form NaOH, which gives a blue color in the litmus, and the reason is because NaOH, which is sodium hydroxide, which is a base basically, NaOH is formed. Question F. Carbon electrodes are used because they are inert. State another element that can be used instead of carbon. We can say that we're using platinum. Platinum, because platinum is also an unreactive element. This question is about compounds of nitrogen. Nitrogen reacts with lithium to form lithium nitride, Li3N. Write the chemical equation for the reaction between lithium and nitrogen. So we have here lithium plus N2, because again, nitrogen is one of the elements that exist as a diatomic molecule. Then the product would be Li3N. So we need to balance this. And how can we balance it? So let's start with looking at the lithium. We have 3 lithiums here and only 1 on the other side. So we wanna 3 here. Now let's look at the nitrogen. We have on the left hand side we have 2 nitrogens, on the right hand side we only have 1. So we need to add 2 to this side to have it balanced. But now that creates another problem, which is we have 2 by 3, which is 6 of lithium ions, and on this side we only have 3. So we're gonna remove this 3 from here and add a 6 instead of it. So now we have 6 lithiums on this side, 2 by 3, which is 6 on the other side. Looking at the nitrogen, we have 2 nitrogens on the left hand side, 2 nitrogens on the right hand side. Therefore, the equation is perfectly balanced. Lithium nitride is ionically bonded. Complete the diagram to show the electronic structure of the nitride ion. Show the charge of the nitride ion. So we know that nitrogen is in group 5, so the nitrogen atom would have 5 electrons, so that's 1, 2, 3, 4, and then 5. So to fill this shell, it needs 3 more electrons to form a full octet. So we're gonna get 3 electrons from the lithium, which would look something like this, and then we're gonna add the 3 minus charge, and this is how the nitride ion looks like. Now let's see question B. Nitrogen reacts with fluorine to form nitrogen with nitrogen trifluoride NF3. The chemical equation can be represented as shown. So that's the chemical equation. Some bond energies are shown in the table. Calculate the energy change for the reaction between nitrogen and fluorine using the following steps. First thing, energy taken in breaking the bonds. So this side is the bond breaking side, the product side. So we gotta look at the bond energy for each bond here. So to start, we can see an N triple bond N, which has a 945 kilojoule per mole. So we're gonna write down 945, and then we have the other bonds, which are FF, 3 FF bonds, which is 160, and since we have 3, we're gonna add 160 by 3 to the 945. That gives us 1425. Now looking at the energy release when bonds are formed, so we have, this is an NF bond, this is an NF bond, NF bonds, so we have 3 NF bonds, and this number is multiplied by 2, so we have 6 of the NF bonds. NF bonds is, each NF bond is 300, so 300 multiplied by 2 by 3, that gives us 1800 kilojoule. Now to calculate the energy change, so energy change is equal to energy taken minus energy released, so that is equal to 1425 minus 1800, and that gives us negative 375 kilojoule, so negative 375 kilojoule per mole. Use your answer to I, so that's question I here. Use your answer to I to deduce whether this reaction is endothermic or exothermic, and explain your answer. So basically, to decide if it's an exothermic or endothermic, we gotta look at the sign of this, the energy change, which is negative in this case. And since it's negative, we're gonna say that the reaction is exothermic because the sign of delta H, which is the change in energy, is the sign of delta H is negative. Complete the dot and cross diagram to show the electron arrangement in a molecule of NF3. Use dots for nitrogen electrons and crosses for fluorine electrons. So dots for N, crosses for fluorine, and then we're gonna start with filling this part. So we're gonna have 1 electron from nitrogen, 1 electron from fluorine, 1 electron from nitrogen, 1 electron from fluorine, and 1 electron from nitrogen, 1 electron from fluorine. But if we look the structure of nitrogen, we're gonna see that the nitrogen has 5 electrons in the outer shell, and it only used 3 of its electrons in bonds. So we'll have 2 extra more in the outer shell, not forming any bonds. And if we look at the fluorine, the outer shell of fluorine, it looks something like this. So we have 7 crosses in the outer shell, 7 electrons. That's 6, 7. Here we have only 1, so we gotta draw 6 more. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Lithium nitride melts at 813 Celsius. Nitrogen trifluoride melts at negative 206 Celsius. Explain in terms of attractive forces why lithium nitride has a much higher melting point than nitrogen trifluoride. In your answer, refer to the types of attractive forces between particles and their relative strengths. So we're gonna say that the lithium nitride has ionic bonds, while the NF3, which is the nitrogen trifluoride, has covalent bonds. And the forces of attraction and the NF3 is weaker than the ones in the Li3 in the Li3N, the lithium nitride. Therefore, the melting point of nitrogen trifluoride is lower than the lithium nitride. Ammonium nitrate NH4NO3 is a compound of nitrogen. Calculate the percentage of nitrogen in the ammonium nitrate. So the first thing we're gonna do is to calculate the molar mass of the whole compound. So we have 2 nitrogens here. Each is 14. Each one has the mass number of 14, so we gotta have 14 multiplied by 2 plus 4 plus O3, which is 16 multiplied by 3. This 4 came from the 4 H's. Also, always check the periodic table to make sure that you have the right values. So the total mass number is 80. Now that's the mass number of the whole compound. Now we want to know the percentage by mass of nitrogen in this compound. So we're gonna make 14 multiplied by 2 divided by 80 multiplied by 100. Now I'll explain why we did this. So 14 came from the mass number of one molecule of nitrogen, and we have 2 molecules of nitrogen, so multiplied by 2 divided by 80 to get the ratio of the mass of nitrogen to the mass of the whole compound, multiplied by 100 to get the percentage, and that gives us 35%. So 35%. Okay. State the use of ammonium nitrate in agriculture. So it's basically used as a fertilizer. State the name of a compound that will displace ammonia from ammonium nitrate. So that would be any base. We can say sodium hydroxide, or calcium hydroxide. Ammonia is a base which forms a weakly alkaline solution when dissolved in water. Define the term base. Base is a proton acceptor. Suggest the pH of aqueous ammonia. So we know that it's a weak alkaline, and we know that strong alkalines have 14 pH. So a weak pH would be something like 8 or 9, 9 or 8, whatever. So I'll just go with 9. And actually the marking scheme gives a kind of big range. So it gives anything from in between 8 to 11. So if you choose 8 or 11 or anything in between them, the answer would be counted as correct. Question 6. Molecules A and B can form condensation polymers. Each molecule has two identical functional groups. Name the functional group in B. So that's B over here, and that's B. We can see a functional group of COOH, which is the carboxyl group. Now draw the part of the structure of synthetic polymer that would form when two molecules of A and B and two molecules of A and two molecules of B combine. Show all the bonds and the linkage. So let's start by seeing what happens in this reaction. So in a condensation polymerization reaction, we form water. So when these two guys react together, we form polymer X and H2O, or water. So we gotta get H2O from somewhere in here. So since the carboxyl group, so that's an alcohol, and that's carboxyl group, or carboxylic acid, carboxyl. So this guy over here has COOH, and this guy has OH. So if we want to take from one of them some molecules, which one are we going to take from the most? We're going to take OH from the carboxyl group, since it has more oxygens than the alcohol, and from the alcohol we're going to only take H. So H from this, OH from that, forms the H2O that is over here. So we're going to do the same thing for every molecule that we're going to use in this reaction. So let's start by drawing the alcohol, the first alcohol molecule. So we're going to take out an H and an H from each side. So it looks something like this. O is connected to a bond, and then another bond with the O, the shaded box, which is this one, and then another O, a bond, and then we're gonna get rid of the OH here. So we're gonna end up with an O, C, and then the white box, and then we're gonna get rid of the OHs here. So we're gonna have CO again. Then we're gonna repeat this part again, this blue part here. So we're gonna have O with the box, O, and then we're gonna repeat this part over here, that part. So we'd have O connected to OC. Let's use the same color. OC connected to a box, and then OC again. So this is how the bonds should look like. So and the reason why we doubled this is because the S for this, they said 2 molecules of A and 2 molecules of B combined. So if we're looking at one molecule, it would be something like this. So that would be one molecule, and that would be the other molecule here, this one here. So that's the answer for question 6A2. Name the other product formed when molecules A and B undergo polymerization. As we mentioned before, that would be water that is formed from the OH and H. So it would be water. Molecule A is a simple sugar unit which can be made by hydrolysis of complex carbohydrates. Draw part of the complex carbohydrate that could be hydrolyzed to make molecules of A, include one linkage, and show all the bonds of the linkage. So for this reaction, we're gonna double up this part with removing OH from one monomer and H from the other one. So let's draw it. Let's draw the two monomers we're gonna use. So we would have OH here and OH here, and that is plus another molecule, similar molecule. That would be something like this. And then we're gonna take OH, one OH and one H from this monomer, and OH from this and H from that, and we're gonna connect that with each other. So we're ending up with an oxygen connected to the box, and then this OH is deleted or removed, leaving us with this oxygen here. So we're gonna connect it and then continue the box, and then we're having nothing in here, so we're just gonna draw a line. So this is how the carbohydrate looks like. State two sets of conditions which could be used to hydrolyze the complex carbohydrate to form A. So the first option would be an acid, the other one would be an enzyme. Both of them can be used to break down carbohydrates into sugars. Name the technique used to identify the individual sugar units made by hydrolysis of a complex carbohydrate. So this technique is known as chromatography. Ethanol can be made from the simple sugar glucose C6H12O6. State the name of this process. So this process is called fermentation, and complete the chemical equation for this reaction. So it's C6H12O6 with yeast used as a catalyst. That gives us ethanol, which is C2H5OH plus carbon dioxide. Now we want to balance this. So we have 6 carbons. Here we have only 2, and there we have only 2. So let's try multiplying this by 2, giving us a 4, and multiplying this by 2, giving us 2 carbons. So we have 4 carbons here, 2 carbons here. So that's 4C, 2C. And then if we look at the hydrogens, here we have 12. Looking at the hydrogens here, we're gonna have 5 plus 6 multiplied by 2, this 2. So we have 5 H's plus 1 H, all multiplied by 2 is 12. So we have 12 H's here, 12 H's here. And then looking at the oxygen, we have 6 oxygens on the left side, and if we count the oxygens here, we're gonna have 2 oxygens and 4 oxygens here. 2 multiplied by 2 is 4, so we're having 4 oxygens, which that's an O, not a 0. So if we add these together, we're gonna end up with 6. So we have 6 oxygens, 6 oxygens, 6 oxygens. So everything is balanced. And that's it for this exam. Please like the video if you benefit from it. Share it with your friends and suggest what the next exam you want us to go over. Thank you very much for watching. Thank you. And have a great day. Bye.